By the end of this lecture, you'll understand how Microsoft Teams ensures high availability for seamless communication and collaboration. High availability refers to a system's ability to operate continuously without downtime, ensuring services remain accessible even during failures or interruptions. In Microsoft Teams, high availability is critical for maintaining voice, video, and collaboration services for users across the globe. Teams is built on Microsoft Azure, which provides global scalability and redundancy. Azure regions and availability zones ensure that if one zone fails, another can take over. Key redundancy features would be the data center redundancy, which Teams is hosted in multiple geographical distributed data centers. So if services fail over to another data center in the same area or a different region. Service level redundancy, which Team uses microservices where each service can scale independently, and that redundancy is built into each layer of the service. And then network redundancy, Microsoft's global network backbone ensures low latency and reliable connectivity. Redundancy, you have SBCs, which you can deploy redundant SBCs for failover. You can use multiple SIP trunks to avoid a single point of failure in the PSTN connectivity. And when you configure fallback routes to alternative SBCs in case of any type of failure with that. Teams calling plans rely on Microsoft Cloud PTSN, which is inherently redundant. And Teams clients automatically reconnect to the nearest available server or failover region if their primary connection is disrupted. So Teams replicates data across multiple Azure regions to ensure availability and disaster recovery. If a service in one region becomes unavailable, Teams automatically fails over to a backup region without user intervention. Teams uses QoS to prioritize voice and video traffic, minimizing disruptions caused by network congestion. Azure load balancers distribute traffic evenly across available resources, preventing overload on any single server or region. Deploy redundant SBCs in direct routing scenarios and ensure SIP trunks are geographically diverse. Use the Teams Admin Center and Call Quality Dashboard to monitor service health and call performance. Set up alerts in downtime or performance degradation. Implement QoS policies for Teams traffic and use ExpressRoute for a dedicated connection to Microsoft Cloud, ensuring low latency and higher reliability. Regularly simulate failover events to ensure high availability mechanisms function as expected, and verify that users experience minimum disruption during failovers. So some scenarios that demonstrates high availability is if one SBC goes offline, the calls automatically reroute to the backup SBC and users experience no service disruption. Or if an Azure region becomes unavailable, Teams fails over to the nearest available region and users can retain access through chat, calls, and meetings. You can even think of a PSTN trunk failure. So if the primary SIP trunk fails, calls are routed through a secondary SIP trunk or another gate. Some considerations and challenges would be to ensure sufficient bandwidth and properly configure QoS to avoid bottlenecks. And high availability configurations involving on-premise equipment like SBCs require careful planning and testing. And deploying redundant SBCs, SIP trunks, and ExpressRoute can increase costs. So just to bring it all together, high availability in Teams ensures uptime for communication and collaboration services. Redundancy is built into Teams Cloud native architecture, but direct routing scenarios require additional planning. Best practices include deploying redundant SBCs, optimizing networks, and monitoring service health.